Alright, this video is going to be a review of linear functions because the next thing that we're going to do has to do with lines and slopes and points, and we want to make sure that we remember how to do all the things that we need to know how to do. So linear functions review. A linear function is defined, or we can graph it, but it's defined by a single point and a rate of change. Which we call a slope. So if we have a single point and a rate of change, we have enough information to write the equation of a line. So the first form that you are probably most familiar with is slope-intercept form. And slope-intercept form is y equals mx plus b, where the m is the slope, and we describe that as rise over run. And you might have even seen it as change in change in y divided by change in x. And the b over here is the y-intercept. So that's the most common form that you've dealt with. We also have standard form. And that's ax plus by equals c. And in this form, it's not apparent necessarily what the y-intercept is and what the slope is. We would have to solve some to be able to graph it. So for the first example, to make sure we're not too rusty on these, we're going to graph the line y equals negative 3/4 x plus 2. So to graph, I'm going to start with my y-intercept of 2. I start on the y-axis. And then my rise over run tells me to go down 1, 2, 3, and to the right 1, 2, 3, 4. So down 1, 2, 3, to the right 1, 2, 3, 4. It's off the page-ish. So that's what that line would look like. I guess in this example I should have had some instructions. Graph that line. For another example, we're going to look at a standard form problem. So let's say they wrote, they wanted you to graph 3x minus 5y equals 30. And you have two options with this. You can solve for y and get this into y equals mx plus b form, or you can use what I like to call the cover-up method. And so the cover-up method recognizes that if you're looking for your x-intercept, your y-coordinate is going to be 0. So if I plug 0 into the equation for y, it would 0 out that part, and I can just cover it up. So that means I'm going to solve the equation 3x equals 30. And I'll divide by 3 on each side, and so my x value there is 10. So I have an x-coordinate of 10. For the y-coordinate, I know that the x value is going to be 0 there, so I can look at my equation and cover up this because it's going to end up zeroing out, so I'll cover that up. And I'm solving the equation negative 5y equals 30. That means that y is negative 6. So then if I wanted to graph this equation, I could just plot the point 10, 0, plot the point 0, negative 6, and connect those 2 points, and that's enough information to form a line. And I'm not going to do that because I think you guys are more than capable. All right, the next example is to find the equation of the line that has the points negative 3, 5, and negative 4, negative 6. So find the equation of the line that goes through those 2 points. So to do this, we need to remember our slope equation. So our slope equation is that slope is y2 minus y1 divided by x2 minus x1. And so that's just saying the y-coordinate for my second point, subtracting the y-coordinate for my first point, divided by the x-coordinate for my second point, subtracting the x-coordinate for my first point. And that gives me negative 11 over negative 1. So the slope between those 2 points was 11. And then to write the equation of the line, I just have to go back and plug in some information. So y equals mx plus b is what we're comfortable with, so that's most likely what we would do. And then I'll go ahead and plug in -3 for the x value, and my slope of 11 for the m value, and plug in my 5 for the y value, and that means I'm going to be solving for the b value. So I have 5 equals -33 plus b, and I can go ahead and add the 33 to the other side, and that gives me that 38 equals b. And so the equation of the line that went through those 2 points would have been y equals 11x plus 38. Okay, that's old news. Next, we're going to learn a new form of a line, and this is the form that we will primarily use in calculus. So the new form of a straight line is called point-slope form, and it uses a point and a slope. So the point-slope form comes from the slope formula. So slope is y1, or y2 minus y1 divided by, goodness gracious, sorry guys, divided by x2 minus x1. So bear with me. What I'm going to do is I'm going to kind of isolate the y's there, because we usually have our equations written as y equals. So I'm going to multiply each side by that group of those x's. So x2 minus x1. And then I'm going to say that the slope times the change in the x's equals the change in the y's. And what I'm going to do now is I'm going to say, well, I'm not looking at a specific point here. I'm not looking at a specific x and y. I'm going to have, or 2 points, I guess you could say. I'm not trying to find a specific answer for a slope. I'm trying to find like a general equation. And so I'm saying, what if I had 1 point and the slope? So I have a number here, and maybe I could have the first point, x1 and y1. Then I'm going to say that this is just going to be a variable y, and that's just going to be a variable x. And it would be something you could just plug another number into. And so the formula for point slope is y minus y1 equals m times x minus x1, where m is the slope that you found, and the x1, y1 are x and y coordinates from a point, and then the x and y are just variables. You're going to leave them as those letters. All right, so that's the slope, that's the x coordinate of the point, that's the y coordinate of the point. So, for example, if it says to find the equation of the line that goes through the point -3, 18 and has a slope of -7, then all you would do is you would take the numbers and plug them into that equation. So we know we're going to have y. So y subtract y1. So y subtract 18 equals our slope. And then x minus x1. So x minus -3 would make +3. And we would leave our answer like that, because all that it takes for us to be able to graph an equation of a line is we have to have a point, which we would have. You can see the point here, it's -318. And then we have to have the slope, we have to have the rate of change, and then we can graph the line. So here in calculus, we're going to use this new form of a line, and we are going to be very specific that we do not simplify this. We write it, we leave it just like that.